Regression is the mathematical modeling of the variables based on a set of values in which we predict one value based on the other equations, other independent variables, other variables. The regression is the next section to the correlation. Once we have a set of variables which are correlated, say x1, x2, etc., xk are correlated, then we can predict any one of them. Say if x1 can be predicted using x2 to xk, then x1 is called the dependent variable and x2 to xk are called independent variable. If we are using only two variables and the relation is linear, that is the mathematical relation between the two variables, say x and y is linear, then we say that it is a linear regression equation. To fit the linear regression or whatever the regressions, we use the method of least squares. Now, before coming in detail, let us say what is regression equations. So first we wanted to find whether there exists any relationship between x and y. For that we calculate the correlation coefficients and just plot the scatter diagram of x and y and let the relation be straight line. That the what we wanted to have, we wanted to fit a straight line in such a way that it should contain maximum point. Normally that is the way we are doing. If we are doing and what the purpose of this is to predict the value. In this diagram uh, we have fitted actually we have fitted three lines, or we are plot three lines based on the scatter diagram, and we wanted to if we wanted to predict the value at the point when x equal to here x is as a value here, then what happened is the red line predict a value, whereas the blue line predict another value and black line predict some other values. So the prediction of the three persons who draw the three lines are different. So this will become a better confusion about the predicted value. Now the question who is right or we use these three lines like this. So the answer to this is that if we want everyone to be predicted the same line, same value, or predicted the fit the same straight line, then we have to use the method of least squares. So in method of least squares, we fit a straight line in such a way that the error terms, sum of squares of the error terms is minimum. Now, what is the error term? So I have a scatter diagram here, and if I fit a straight line is given here. How this fitted line should be fitted is explained in a later stage. Now I have fitted a line which comes to 2 points, and other 5 points are out of the line, but this here I am given e1, e2, e3, e4. So e1 and e2 is the difference between, this is the actual value at the point 4, and yeah, yeah, point in the value, that is this is the actual value. Y value is something about around 5, but actual value is 5, but the fitted value in the regression is about 6. So here it is 6, but this is 5. So difference between 6 and 5 it should be 1, and this is called a first error term. So likewise we have E2, E3 and E4. In general we represent it by EI. So it's the difference between actual value and the expected or the fitted value, that is value on the regression equation. So these values are called error terms. So, and this is a basic thing we wanted to know before going to the least square methods. So we have a observed n pair of variables xi yi from a sample, and we called each pair, that is x1 y1 is called a case, x2 y2 is another case, etc., is called a case. Here y the ith response of variable, and xi called the dependent variable, and xi the ith explanatory variable or independent variable. Initially we assume the regression to be y equal to, means the mathematical relation should be y equal to b naught plus b1x. uh, but in reality this may not be the case, because there should be some error occurs due to the uh, natural or calamitic condition. For example, consider agricultural productions. So if let x denotes the year and y denote the production, and it is going on smoothly, and the relation is everything we y equal to b naught plus b1x. But suddenly one year there should be some heavy rain, and the production comes to be died. So if we have expected, we have given the values, if let it y equal to 100 plus 10x, and if you put the value for x equal to 1, it is 110, x equal to 2, it is 120, x equal to 3, it is 130, and then x equal to 4, it become 140. So at the fourth year we are expecting a 140 tons of production, but due to this rain, the agricultural production is destroyed, and it reduces to 80. So the actual value we wanted to have is 140, predicted value is 140, and that actually it comes to be 80. So there is an unexpected thing happened there, and this may be happen every year, may not be happen. If in order to accommodate this unexpected thing, we assume ya as a random variable, and add an error term called epsilon I. So and this epsilon I is assumed to be normally distributed with mean equal to 0 and variance sigma square. So a and ej, now again ea and ej are, that is the correlation, successive or any two correlations between the error variables are 0, or they are uncorrelated. Here b naught is called the intercept and b1 is called the slope. Now what its least square method says. So the least square methods, we can define from the above equations, we can define ei equal to ya minus b naught plus b1 xi xi. Now again define e equal to sigma ei squared equal to ya minus b naught minus b1 xi whole squared, and this e is called the sum of squares of residual errors, or sum of squares of error, uh, also called sum of squares of residues. And the principle of least squares, as a definition, the principle of least squares state that the best value of b naught b1 is that value which minimize e. So we have to find b naught b1 which minimize the error residual term. Again here a problem is there. Actually we have n equations, and n plus m terms, here b naught b1 plus n ei, so n plus 2 terms. So that is what we go for uh, least square method. So what we have to do is we use the principle of calculus. Maybe you may not be familiar with that, or some of the persons who have studied mathematics in the plus 2 level can know what is maxima and minima. So anyway, the solving that we can get a equation sigma ya equal to nb naught plus b1 sigma xi, and sigma xi ya naught equal to b naught sigma xi plus b1 xi square, which gives b1 has sigma xi minus x bar into ya minus y bar sigma xi minus x square b naught equal to y bar minus b1 x. Actually, this is a, you can write this is a simple way. Actual equation is y equal to b naught plus b1 x. You sum it. So the first actual equation is, again I say, y equal to b naught plus b1 x. I sum it. So sigma y by sigma b naught plus sigma b1 x. Since b naught is sum n times, then we have sigma ya equal to nb naught plus b1 sigma xi. Now the second equation, multiply the first equation with xi. So sigma ya equal to sigma xi b naught. B naught actually here b naught sigma 1 is here, that tends to 1. So 1 into xi is xi, and sigma x into xi is xi squared. That is the second equation. So the solving you got this b1 and b naught. So as an example is given here, how we calculate the regression lines. So y equal to, and here equals xy, we calculate x, xy, x squared and y squared. So it's x squared and y squared, and substituting from this, though you got x equal to 30, y equal to 40, xy equal to 266, x squared 220, and y squared is 340. So these values are substituted here, and we solve the equation. We get b1 equal to 0.65, and that substituting in first equation. So giving in here b naught, b1 is 30 into 0.6, so 5b naught equal to 40 minus 30 into b1, or 30 into 0.565, which gives you b naught equal to forward. So we substitute in the first equation y equal to b naught x b1 x1 plus b naught. So that reduces to y equal to 0.65x plus 4. This is equation y on x. So the first one we write the dependent variable, and the second one independent variable. Now consider the reverse equation. So we consider, let x as the dependent variable and y as the independent variables. So the equation should be of the form x equal to c dy. So I sum here. So sigma xi plus c is sigma 1, that means nc, plus d sigma ya. Again, mm, the second equation, multiply this with ya, because x is the dependent variable, so we can to multiply it with ya. So sigma xi ya equal to c sigma ya plus, actually there is a mistake, it's not b1, it is d sigma ya squared. So here it is, instead of b1 it is d, it's a mistake. So substituting the value, from the table, already we have computed sigma xi ya, sigma ya, sigma ya squared, and sigma xi. So substituting this value, we get the two equations like this, and by simple mathematical calculation you get x to be 0.13y minus 411. Now what I am testing is whether I can arrive this equation from the earlier fitted y equation. So from 1 I have y equal to 0.65x plus 4 plus 4.1. So I revise it into, as I write it in terms of x, what I got is this one. But here you can observe that x1 and x equation 2, that is x fitted, actually fitted x equation, and the calculated x equations are here, it is y actually fixed execution and calculated executions are different. So there is a mistake. Please correct that this is why. So one can clearly see that it is though these two equations are different. That is, we cannot invert one equation to reach the other equation. So the equation y on x and equation x on y are different or unique. So the question why this happens, why this have to have two regression lines. This is because of the basic assumption that we have made in the initial stage about the EA or adding when we add EA. So in when we fit y equal y on x, that is when we fit the regression line with y as dependent variable and x as independent variable, we assumes that y is a random variable and x is a random variable. Similarly, when we revise the equation with x as dependent variable and y as independent variable, we assume x as random variable and y as non-random variable. Because of the difference in this basic assumption that we have made earlier, we cannot able to invert one equation to other, or the two regression equations are quite different. So we have already defined the in correlation b sigma xi minus x bar by y minus y bar equal to pxy, and sigma xi minus x squared equal to sigma x squared. So and so substituting this in the equation, already we have finding earlier b0 and b1, we get the regression equation y on x as y minus y bar equal to px by sigma x squared into x minus x bar. So y minus y bar is actually uh, in a nutshell, we can say that y minus y bar equal to byx into x minus x bar. So a regression equation y minus y bar can be written on the left side. You write y minus y bar, and on the right side the dependent variable first, y independent variable second, and x minus x bar. Again, I repeat a regression equation on y the independent dependent variable and x independent variable is taken written as y minus y bar. First write the dependent variable, then equal to b by x. For that the first suffix is the dependent variable and the second suffix is independent variable and x minus x bar. So where byx is, remember, r is common factor, r into first one standard deviation in the upper side. So the r sigma y by sigma x. So similarly, so you can write the regression equation x on y. So dependent variable being x. So first one is x minus x bar into b x y minus y bar, where bxy is r sigma x divided by sigma y. So that is written here, x minus x bar equal to r sigma x by sigma y into y minus y bar, or x minus x bar equal to bxy y minus y bar, where bxy is r sigma x by sigma y. And here bxy and byx are called the regression coefficients. So byx is called the regression coefficient of y on x, and bxi is called the regression coefficient of x on y. And the some properties of regression coefficients, if you multiply the two regression coefficient, so one is r sigma x into sigma y, sigma x by sigma y, other is into r sigma y by sigma x. So here r, this one is repeated with, instead of sigma x, here it comes sigma y. Here in the bottom it comes sigma x. So this sigma y and this sigma y, here sigma x and sigma x get cancelled, and one r is remaining here. The other r of the byx is there. So if you multiply both, you get it to be r squared. So bxax into bixr, or r equal to root of bix into bxi. One thing is to be remembered, that r is a signed one. R may be take positive value or negative value. So if r, to find out whether r is positive and or negative, depends on the value of byx and bxy. If one bx, if byx and bxy are both negative, then r is negative, and if byx and bxy are both positive, then r is positive. Remember that byx and bxy are always of the same sign. They may not have a different sign. So r, sign of the r depends on byx and bxy. So this is the working formula to calculate. So whenever you do the problem, you can use this byx equal to sigma xy by sigma x squared, bxy equal to sigma xy by sigma y squared. So the right in the, on the numerator always you have sigma xy, and on the denominator you have the second variable. So second suffix, that is here yx comes, x comes the second, here bxy comes, so y is the second, so sigma y square. Where to do that, the first calculate x bar and y bar, then you calculate xi equal to xi minus x bar, ya equal to ya minus y bar, and then compute xi ya, xi squared and ya squared, and calculate the coefficient. Then you can write the two regression line, and finally you can write it in that. And the first example I have showed that always you write y equal to some value x plus c. So this form you can have to, first you write this one and then reduce this into the form. So an example is given uh, there. So what are the properties of a regression line is that uh, when r equal to 1, the two lines coincides. That is, one come over the other. If you usually write the two regression lines, they are like a cross x in the regression line. When r equal to say, they are perpendicular to each other. That is, I'll show you. Uh, yeah, the regression lines, if you plot it like this, let this be xi, and this will be the regression line y on x, then this will be the regression line x on y. And this act, if r is 1, both the line are like this, one on the other, and if r equal to 0, they are like perpendicular to each other. So that is what mentioned here. When r equal to 1, the two lines coincide. When r equal to 0, the two lines are mutually perpendicular. The two regression lines are uh, the are the same common point, that is, again, if like this, if you have like this, these are the regression x y on x, and x on y, and this common point, this point is called x bar y bar. Okay. Now the last remaining problem is how to, if normally we have will give two regression like equation like this, 14x plus 12y minus 3 and 12x plus 21 minus y plus 10 equal to 0. And the problem is one of them is y on x and the other is x on y. How to identify this? For this, first take a one of this. I take this first equation as y on x, and I write the equation in the form y equal to y, the coefficient of y equal to x plus c, and where y has a coefficient 1. So I first take this 12y to the other side. So 12 minus 12y equal to 14 minus x minus 3. When I divided with minus 12, I got y equal to minus 14 by 12x plus 3 by 12y. And by the definition, this value, this coefficient is byx, y equal to this coefficient is equals. So I got byx equal to a equal to minus 14 by 12. Similarly, when I once I take this as y on x, and naturally this will be the x on y. So this had been written in the form x equal to cy plus d. So we have as transferring this, I take 12x to the other side, and so 12, minus 12x equal to 21 by plus 10, and then when I divide with minus 12, I got x equal to minus 21 by 12 into y minus 10 into 12. Then the coefficient of y is taken as the regression coefficient px on y, which is minus 21 by 12. So and when I calculate r using the formula root of b by xy, so what I got is 2.044. But we know that the correlation coefficient is always lies between minus 1 and plus 1. So but what we got here is, here the value is 2.04, which is greater than 1. So we cannot use it, or our assumption is incorrect. So we take the regression equation y on x as the second one and x on y as the first one. And that case we get byx equal to minus 12 by 21 and bxy equal to minus 12 by 14. And so we calculate r, it tends to be minus 0.49. So here both bxy and byx are negative, so the correlation is negative. So this is the given here in terms of how to write when there is a question, how will you identify the regression line. So let there be two regression lines. First assume one equation as y on x, and let's write that equation in the form y equal to ax plus b, then byx equal to that, the coefficient of y should be 1, and that should be on the left side, all other are take to the right side, and then you get a value such of a of the form y equal to ax plus b, then a is taken as the regression coefficient y on x. Similarly, you can write x equal to cy plus 2, where if you have said the first equation as y on x, then naturally the second equation turn to be the x on y, and you find the r equal to root of byxy into bxy. If r is less than or equal to that calculated r value is less than or equal to 1, then our assumption is correct, otherwise we have to revise it. Now another question remains here is to find out the mean of the x bar and y bar. Then that for that what we are doing is we solve that two equations, because x bar and y bar are common to the two regression equation. So write the two regression equations simultaneously, replacing x and y with x bar and y bar. Then you solve the equation, you get the value of x bar and y bar. So this is done to obtain the value of x bar and y bar. So before conclusion, I just wanted to give you a small tip to identify uh, the regression level correctly. So here you are given two equations, 40y plus 66, 8x minus 10y plus 66 equal to 0, 40x minus 40x minus 18y equal to 14. So looking into this equation, we can see that this 40 plus x is the maximum coefficient of x and y. So this equation is taken as the equation x on y. And so the things look into both the equations and look which coefficient has maximum value. So x coefficient here in the equation second is maximum value. So it is taken as the regression line x on y. If instead of this, if here you have 50y instead of 10y, if equal to here uh, sorry here instead of 40x minus 18y, if you have here it is 60y, you should take it as the y on x instead of x on y, like that. So if you have looking into just, you can control, you can find out which one should be taken as x on y and y on x. So simple thing, go for the coefficient, the largest coefficient, find the garage coefficient and the variable which has that coefficient, and that equation is taken as the variables equation. That is, here you can have x is taken. So x is taken as the uh, dependent variable. So these are some diagnostic method. Uh, so thank you for your patience.